Hey guys, so in the previous video we have learned that a random variable can be decomposed into its fixed and random components, and we can recall from the previous video that the random component, which is denoted with the letter U, is equal to the difference between the actual value from its mean, that is mu x. And in this video we're going to prove that the variance of x is equal to the variance of U, that is the random component. Now, before I proceed, I must remind you that in the previous video, we have also learned that the expected value of U, that is the population mean mu U, is always equal to 0. So we're going to use that in today's video. So if you don't already know why I have written that, you can watch my other video. I'll leave a link in the description box below. Okay, so this is always equal to 0. Now we know that by definition, the variance of x is equal to the expected value of the square of the difference between x and its mean, that is mu x. Now notice that this expression right here inside the brackets is the same as this expression right here. So this is basically the same as the equation for U, that is the random component. So we can replace U over here, right? So I'm going to do that. Therefore, sigma squared x becomes expected value of ui, the whole thing squared, and this is basically simply expected value of u squared. So next we're going to prove that the variance of u is also the same as the variance of x. So we know that the variance of u, again by definition, is simply the expected value of the square of the difference between u in any given observation and its population mean, that is mu u. And we know that mu u is always equal to 0, right? That's something we've already proven in the previous video. So the expected value of ui, that is mu u, is equal to 0. So therefore this expression over here becomes the expected value of ui minus 0. And this can be simplified further. So we have proven that expected value of ui is equal to, expected value of u, the whole thing squared, is the same as the expression that we got for the variance of x. So we have proven that the variance of x is equal to the variance of u. As always, please pardon my handwriting.